Somewhere around 74,000 years ago, the sky turned black for 6 years straight. Not cloudy, not overcast, black. The sun barely broke through. Global temperatures dropped by several degrees almost overnight. And somewhere in that darkness, a small population of humans should have died out completely. They didn't. This is the story of the Toba supervolcano, one of the most violent eruptions in Earth's history. And the question it leaves behind is almost uncomfortable to sit with. How did a species with no metal tools, no permanent shelter, and no understanding of what was even happening to the sky survive a volcanic winter that wiped out entire ecosystems around them? Here's what makes this stranger than it sounds. Volcanic winters aren't gentle. When a supervolcano erupts, it throws sulfur particles high into the atmosphere, where they block sunlight for years. Crops fail, if crops even exist yet. Plant life collapses. Animal populations crash. Some researchers have proposed that Toba's eruption pushed the entire human species down to a genetic bottleneck of just a few thousand individuals worldwide. A few thousand out of the entire human race. So how do you explain what came next? Because instead of vanishing, human populations recovered. They spread. They eventually built cities, languages, and civilizations. Something helped them survive conditions that should have erased them from the planet. Let's start with the obvious question. Wasn't this just about physical toughness? That's what most people assume, but here's where things get strange. Physical strength barely factors into surviving a volcanic winter. You can't out-muscle 6 years of darkness. You can't run faster than a collapsing food chain. What you need instead is something far less visible and far more interesting. Anthropologist Curtis Moran spent years studying early human sites along the coast of South Africa, in caves like Pinnacle Point, dating close to this period of extreme climate stress. What he found challenged a major assumption about how our ancestors survived. These groups weren't relying purely on hunting large game, which would have been nearly impossible with collapsing ecosystems. Instead, evidence showed heavy reliance on shellfish, a stable, weather-resistant food source along the coastline. That's one piece, but it's not the whole answer. Then scientists discovered something even more unexpected. It wasn't just what early humans ate, it was how they thought. Around the same period, researchers found early evidence of symbolic behavior, ochre pigments carved with deliberate geometric patterns, simple ornaments, signs of ritual. To modernize, this looks like decoration, but to anthropologists, it suggests something far more important, the emergence of shared meaning between individuals. Why would symbolic thinking matter during a climate catastrophe? Because catastrophe isn't just physical, it's psychological. When your entire environment turns hostile and unpredictable, panic becomes a bigger threat than starvation. Groups that could communicate abstract ideas, plan for uncertain futures, and maintain social cohesion under extreme stress had an advantage that strength alone could never provide. This connects to something modern psychology has confirmed. Research by psychologist John Leach, who studies human behavior in survival situations, found that during extreme crises, the majority of people freeze, not panic, freeze. Only a small percentage react with clear adaptive decision-making. What separates them isn't raw toughness, it's the ability to convert fear into structured action. Now scale that idea across generations of a volcanic winter. Groups that could organize, share resources, and maintain some sense of psychological stability weren't just surviving individual crises, they were passing down behavioral patterns that increase survival odds for everyone connected to them. But the real mystery is this: why would evolution favor psychological resilience over pure physical dominance in the first place? This is where things shift from strange to genuinely fascinating. Evolutionary biologists studying cooperative species have found that resource unpredictability, exactly what a volcanic winter creates, tends to favor social intelligence over brute strength. When food sources become inconsistent, the ability to share, plan, and cooperate becomes more valuable than raw power. Selfish strength might win in short bursts, but long-term survival, especially through unpredictable disaster, favors connection. In other words, the volcanic winter may not have simply tested human bodies, it may have acted as a filter for human minds. That's when everything about this period starts to look different. We tend to picture early humans as primitive, reactive, barely surviving moment to moment, but the evidence tells a different story. These were populations capable of abstract thought, symbolic communication, and coordinated long-term planning, all while living through 6 years without a normal sky. And that raises an uncomfortable question for us today. If early humans needed psychological adaptability and social cooperation to survive a climate disaster they didn't cause and couldn't predict, what does that say about the traits that actually define human resilience?
Maybe survival was never purely about physical endurance. Maybe it was about the ability to stay connected, stay adaptable, and keep thinking clearly when the world stopped making sense. The volcanic winter ended, the sky eventually cleared, but the humans who walked out of it carried something forward that no eruption could destroy: the ability to face chaos not as individuals, but as a species capable of thinking its way through the dark.